There is a zombie outbreak in the town of Somersville. There are 500 zombies at the beginning of the outbreak. The zombie population appreciates by 25% each week for 2 years. After 0 weeks have passed, the population is 500. After 1 week, the population is 625. After 2 weeks, the population is approximately 781.25 zombies. The start equals 500 zombies. Next equals now times 1.25. This means to get the next value of zombies after a week, you have to multiply the previous by 1.25. Y equals 500 times 1.25 to the x power. Keep in mind that x equals 1 week. Predict the number of zombies in Somerville after 1 year. I know that 1 year equals 52 weeks, so I plugged in 52 for x. After raising 1.25 to the 52nd power and solving, I realized that after 1 year, there would be 54,738,220 zombies. Predict how long it would take for the zombie population to be 3,000. After plugging in the equation to my calculator and graphing the values, it would be between 8 and 9 weeks that the population would be around 3,000. To make the graph after 1 week, it would be 625, 2 weeks, 781, and 3 weeks, 976, and so on. The cost for a furniture set is $12,000. The price decreases by 8% every 8 months. This is a graph of an 8-month period timetable with the cost starting at $12,000 and decreasing by an 8-month period each time. The start is $12,000. Next equals now times 0.92. This means that you have to multiply every previous value by 0.92 to get the next value. Y equals 12,000 times 0.92 to the x power. Keep in mind that x is an 8-month period. Predict the cost of a furniture set after 46 months. 46 months into 8-month periods would be 5.75. After substituting 5.75 for x, the cost for the furniture set after 46 months would be $7,320. When the cost of the furniture set would be below $5,000, I plugged in the equation to my calculator and put in the table of values. So after looking through all the values, I realized that after 11 8-month periods, the cost would be below $5,000. 11 8-month periods is also known as 88 months. So the cost would be below $5,000 after 88 months. Just click record and start.
The number of zombies in 2020 decreases every year. If there are 2,000 zombies in 2020, then 300 will die every year.
Y equals 1,
So we have our table.
9, because that's the start value.
Or in 2020, we have
8.
2,000 zombies.
That's how many
In 2021, we
ones
have
that it doesn't kill
one
to the power of x.
1,700 zombies, and in 2022 we have
So,
1,400
and then now the questions.
zombies, and
How
on and
many?
on. Now for
How
our
many hours
recursive
until the one crowd
equation,
reaches 10,000?
we
just have to
have
plug the
start
equation into our
equals
calculator,
2,000,
and it will
because
be
we start with 2,000 zombies,
7 to 8.
and it will be next equals now minus 300, and turn that into an explicit equation. We have y equals negative 300x plus 2,000.
We just need to plug that in.
For our first problem, you have a group of survivors want to know if there will be any zombies left in the future. So they ask you for help. How many zombies will there be in 2040?
And we find that
So
the answer to a question
if we plug in
2 is
if
8.
we plug in 2040, which would be 20 years after 2020. So we plug 20 in to the x spot, and that will be, if you do negative 300 times 20, that will be Negative 6,000. Negative 6,000. Then you would add 2,000 for the equation, and you will get negative 4,000 zombies. For our second problem, after observing from their home, the group realizes that there are only 1,100 zombies left. The group has also lost track of time and wants to find out what year it is. So if we use our problem again, we can plug in 1,100 for y and then solve. So we minus 2,000 from each side to get rid of that, and we will have negative 900 equals negative 300x. Now, to get rid of the negative 300, we will have to divide by negative 300 on both sides, so x equals 3. So use your table, and 3 years after 2020 is 2023. So our answer is 2023. And our graph we have right here is decreasing as the amount of zombies is going down. No. The number of zombies in the world increase every year. In 2015, there are 1,000 zombies, and 200 people become zombies every year. So we have our table, and in the original year, so 0 years have passed, it is 2015, and there are 1,000 zombies. And after 1 year passing, it's 2016, there's 1,200 zombies, and etc., etc. We have our graph right here, and as you can see, we have 0. At 0 years, we have 1,000 zombies, where our first dot is, and then 1 year, we are at 1,200. In 2 years, we are at 1,400, and it goes on. So if we use the information we have here, and write an explicit rule and a recursive rule, we should get, for our next equals now will be start equals 1,000, because we start with 1,000 zombies, and then next equals now plus 200. Now, and our explicit would be y equals 200x plus 1,000. So for our first problem, it is how many zombies will there be in 2030? So 2030 is 15 years after the apocalypse starts, so that will be 15 will be our x. So if we plug in 15 into our equation, we'll have 200 times 15 plus 1,000 equals y. So if we do 200 times 15, we will get 3,000, and then if we add 1,000, we'll get 4,000. So y equals 4,000, meaning we have 4,000 zombies in 2030. For our second problem, if the zombie population is at 3,000, what year is it? So if we use our equation again, y equals 200x plus 1,000, we can plug in 3,000 for y. So it will be 3,000 equals 200x plus 1,000. The first step would be to minus 1,000 from each side, getting 2,000 equals 200x. And you would need to divide by 200 on each side to get rid of the 200. And you should get 10. So 10 years from 2015 is 2025.